Today, we will see how do we find the value for all trigonometric functions just knowing one of them. So what do I mean by that? You gotta remember that there's 6 types of trigonometric functions that we have talked about. We have talked about sine, we have talked about cosine, we have talked about tangent, we have talked about secant, cosecant, and we have talked about cotangent. Now, it is possible for us to find the value for all 6 trigonometric functions just knowing one of them 6. So that's going to be our objective for today. The main idea here is that we can find all trigonometric functions or the value for all the trigonometric functions just knowing one of them. If we know sine, then we can know what cosine, tangent, secant, cosecant, and cotangent is. If we know cosecant, we can find the rest of them. So let's get started. Now, here we gotta understand what is being given to us. So let's see. It says the value of one of the trigonometric functions of an angle theta is given along. So here in our first example, they're giving us the value of sine, and they're saying sine of theta equals 3/4. That's great. And they're also giving us on which quadrant our value is located at. Here it's telling you that this is the first quadrant. Q1 is first quadrant. So they're giving us the function. They're giving us where it's located at. So now what we need to do is we need to find the values for the other 5 trigonometric functions. So they're giving us sine. They're giving us where it's located. Now they're telling us to find the other 6. So there's a series of steps here. Now the first thing that you would like to do is sketch what you've been given. We're talking about quadrants. So no, we're going to talk about some coordinate points here. So let's do our plane. You remember that this is your first quadrant. This is your second quadrant. That's your third quadrant. And that's your fourth quadrant. So let's see, we know that our value it's in the first quadrant. So we're going to concentrate on what's happening here in the first quadrant. What we're going to do is we're going to draw a right triangle on the first quadrant. It's supposed to be a right triangle. So here's a right triangle. It's in the first quadrant. That's why I'm drawing it on the first quadrant. Now, the angle of reference, it's always going to be the angle closest to the origin. So that's theta. Good. So we got a triangle in the first quadrant. Now we need to place this piece of information. The sine of theta equals 3/4. For this, we got to remember our SOHCAHTOA. Here, we know sine, so we're going to use the SOH part. Because we know that sine of theta that's equal to the opposite divided by the hypotenuse. So with the information that they're giving us, we know that sine is equal to 3/4, and we know that sine is equal to the opposite of the hypotenuse. So that says that my opposite is going to have a value of 3, and my hypotenuse is going to have a value of 4. So we're going to come back to our triangle that we draw here, and we're going to place those values. Opposite, this is the angle, so this is the opposite, and we found out that the value for the opposite is 3. And the hypotenuse, it's right here, so that is 4. So all we did is I'm going to erase this because we might need the space. All we did is we just place the info that are given. So our next task is to find out the side for all the pieces of this triangle here. We know the hypotenuse. We know the opposite. We want to find out the adjacent. We remember that this is a right triangle. If it's a right triangle and we're talking about sides, then we can use the Pythagorean theorem. So we're going to use our Pythagorean theorem. And if you remember your Pythagorean theorem, it's a squared plus b squared equals c squared. So let's use the Pythagorean theorem now. So, okay, let's try to make a straight line here. Close enough. All right. So what do we have here? A squared, that's the adjacent. So we don't know the adjacent, so that's a squared plus opposite square, which is 3 squared, equals hypotenuse square. So that's 4 squared. So now let's simplify this. We got a squared, 3 to the second is 9, 4 to the second, that's 16. Let's solve for a, so minus 9. So we know that a squared equals 27. So here, we're going to take the square root because we want to find out just the adjacent. Square root cancels out. So we know that a is equal to the square root of 7. We know that the adjacent is equal to the square root of 7. So let's place that in our triangle here. Excellent. So this is, once you have the information for every single side of your triangle, you have enough information to find the value for the other 5 trigonometric functions that we're looking at, because sine, we know what sine is. So now, well, let's use the tool. Now inside this box, this is where we're going to be finding our values here. So sine has been given. All right, so let's see, what cosine? What is cosine? Cosine from SOHCAHTOA, we know that cosine is adjacent over hypotenuse. So we're going to look at our triangle here. What's the value for my adjacent? We found it to be square root of 7, okay? And the hypotenuse is 4. So that means that cosine is equal to square root of 7 over 4. And that's it. Now let's find tangent. We know that tangent is equal to the opposite over the adjacent. But now, we're going to get these values from the triangle that we just found out here. So the opposite is 3. The adjacent is square root of 7. So that means that our tangent is equal to 3 square root of 7. Now, what's another trigonometric function that we need to find? We need to know what secant is. But remember that secant is the inverse of cosine. So if cosine is square root of 7 over 4, then that means that the secant is 4 over the square root of 7. Now we need to find out cosecant. But remember that cosecant is the inverse of sine. But we know that sine is 3 over 4. So that means that cosecant is 4 over 3. And lastly, we need to find out cotangent. But we know that cotangent is the inverse of tangent. So if tangent is 3 over the square root of 7, so that means that cotangent is the square root of 7 over 3. So we're done. We have found out the 5 trigonometric functions. just knowing sine. So now, let's look at another example here. Again, they're giving us cosine, and they're giving us the location. We need to find the other 5 trigonometric functions. So what we do here is we first just do your coordinate point or your coordinate plane. Which quadrant are we on? We're on the 4th quadrant. So let me just make this a little bit larger. We're on the 4th quadrant, so let's draw our triangle here on the 4th quadrant. So here's a right triangle. Where the angle reference is the closest to the origin. So what do we know here? We know cosine, but if we remember our SOHCAHTOA, we know that cosine is equal to the adjacent over the hypotenuse. So that says that the adjacent has a value of 12 and the hypotenuse has a value of 13. So let's place that in. This is the angle. This is the opposite. We don't know anything about the opposite. So that means that the adjacent is 12 and the hypotenuse is 13. All right. So what are we missing? We're missing the opposite. So what can we do to find the missing side? We can use the Pythagorean theorem. We're going to use the Pythagorean theorem to find the missing side because it's a right triangle here. So what do we have here? We know that the adjacent, which is 12, so 12 squared plus b squared, because we don't know the opposite, and that is equal to 13 squared. So now we see, 12 squared, that's 144, plus b squared equals 13 squared, is that 169? Let me just double check. So 13 times 13. So it is 169. So we have 169 here. So let's solve for that b. So that's minus 144. Let's continue here. So now we have b squared. And now 169 minus 144. That gives us 25. So take the square root. So b is equals to just 5. Excellent. So we know that the opposite is 5. But now, stop here and let's see if this makes any sense. Notice that in quadrant 4, this is your y values here. These are your y values. And what do you know about the y values in the quadrant 4? We know that the y values are negative here. So that means that our opposite is not just 5, but negative 5. That is because we know that the length is 5. But because we're talking about the negatives, we're talking about quadrant 4. And in quadrant 4, your y's are negative. So that means that your value needs to be of negative 5 here. So now we have enough info. Once you have the value for your whole triangle, then we can find the other missing sides. So let's see. What do we have here? Let's find out what sine is. Sine of the angle. We know that from SOHCAHTOA. Sine is equal to opposite over hypotenuse. We know the opposite is negative 5. And we know the hypotenuse is 13. So that means the sine is equal to negative 5 over 13. We know cosine. Now we need to find out tangent. But we know that tangent, that's equal to the opposite over the adjacent from SOHCAHTOA. Opposite, we found it to be negative 5. Adjacent, we found it to be 12. So that means that tangent is negative 5 over 12. Now we need to find out sine, cosine, tangent. Now we need to find secant. But remember that secant is the inverse of cosine. So if we know that cosine is 12 over 13, that means that secant is 13 over 12. Now we need to find out cosecant. But we know that cosecant is the inverse of sine. So if sine is negative 5 over 13, that means that cosecant is negative 13 over 5. And lastly, we need to find out cotangent. If we know that tangent is negative 5 over 12, that means that cotangent is negative 12 over 5. So now we're done. We found the value for the 5 trigonometric functions just knowing cosine. So here's your entrance ticket. Given the following, just find cosine and tangent. Don't find the 5 trigonometric functions, just find cosine and tangent given the following.